Hi, and welcome to this applied structure determination question, which requires relatively little recall. It's virtually all about thinking with the information that you're given, a lot of which will be unfamiliar to you, so it'll seem a bit strange at first, but it is actually doable if you take a sort of logical step-by-step approach. It happens to be question 5A, part 4 from the OCR Unified Chemistry 2017 paper. So it says propane 1,3-dithiol reacts with carbonyl compounds in a condensation reaction to form a cyclic organic sulfur product. And it asks you to write an equation for the reaction of propane 1,3-dithiol with propanone using structures for the organic compounds. So thiols aren't on the OCR specification, and in most A-level specifications they're not present either. So at the beginning of the question it gives you this information. It tells you they're foul-smelling organic sulfur compounds with the functional group SH. Now it's quite useful to think about sulfur for a moment. It's in group 6 alongside oxygen, and clearly you'll come across OH as an alcohol or hydroxyl group. So it shouldn't be too difficult to imagine that SH would behave in a similar way. So let's look at the information they give you. It tells you that a condensation reaction is formed to make a cyclic organic sulfur product. There's 3 bits of info this means. H2O is released, the structure has a ring in it, and the sulfur part of the thiol is retained somehow. So if we take propane 1,3-dithiol, you have 3 carbons in the chain, hence the propane part, and the 2 thiol groups at either end, that's position 1 and position 3, hence dithiol. Then we just take propanone, which is a familiar looking carbonyl compound from many OCR specifications and other exam boards too. And obviously we're going to add them together to make something plus water, because we said earlier, didn't we, that H2O is released because it's a condensation reaction. So far so good. Now's the difficult bit. We have to try and think about how the propanone and the propane 1,3-dithiol might combine together, releasing a water and retaining the 2 sulfurs. So think about where the 2 H atoms in the water are most likely to come from. The water gives you quite a lot of clues. So there's 2 hydrogens, maybe 1 from each of the 2 SH groups. And there's also the fact that there's an oxygen in the water. There's only one place that could have come from, and that's going to be the carbon double bond oxygen in propanone. So what we mean is this oxygen will end up here, and these 2 hydrogens could end up here. So if we visualize those 2 coming off and that coming off, if the oxygen comes off, that carbon in the middle now has 2 spare bonds. So 2 spare bonds could go onto the sulfurs, couldn't they? Because each of the sulfurs now has a spare bond if we've taken the hydrogen away. So if we visualize that, that will give us this. Okay, having a quick check of the mark scheme, well, that's exactly what you get, because you can obviously see I've just lifted that structure from the mark scheme. But hopefully it makes sense how you might be able to problem solve your way there. Okay, as always, thanks for listening. Until next time, see you soon.